Here we are. Let's look at 195. All right. Express this as a summer difference. Oh boy. So this video specifically, I'm just trying to find the messiest homework problems. All right. Easy stuff. We already did the easy stuff. Let's do the gross stuff. You get 3x to the fourth plus x cubed. Plus 20x squared plus 3x. Plus 31 over x plus 1 times x squared plus 4 squared. Lots to talk about before we start. What's the degree? Degree on the bottom is 5. Degree on the top is 4. Thank the Lord we do not have to divide this out. I don't want to divide this out. And luckily we don't have to, because we only divide if the degree on the top is at least as big as the degree on the bottom. It's already factored for us too. We have one linear factor and a repeated quadratic factor. And specifically, this is not reducible. We can't factor this. If we could, we would. But we can't factor it. So we're ready to jump right into it. We got a linear term, so it'll be some constant over x plus 1. And then a quadratic term, so a linear term on top, divided by the quadratic term, and it's repeated, so we have another one, dx plus e. And now we have x squared plus 4 getting squared. Now we're going to multiply both sides of this equation by the LCD. This x plus 1 times x squared plus 4 squared, so we can solve. The left-hand side will always just cancel those denominators. And on the left-hand side, we are just left with 3x to the fourth plus x cubed plus 20x squared plus 3x plus 31. Really, having a bunch of terms here doesn't make it much worse. Like, there's a little bit more to write at the start, but the actual solving's not much worse. Now, when we distribute on this right-hand side, the x plus 1s are going to cancel on this first thing. We're just left with a times x squared plus 4 squared. And now we have a bx plus c. This is so bad. But not because of the numerator. It's bad because of the denominator. The x squared plus 4, one of them is going to cancel. We have an x plus 1 and one of the x squared plus 4s. I'll show you guys why this is so bad soon. And then the last term is the dx plus e. Both x squared plus 4s cancel, and we just have an x plus 1. So this is so bad because strategic substitution doesn't get as much mileage as we want it to. Because of complex numbers. You know what? I'm pretty sure you can plug in complex numbers. I'm gonna plug in complex numbers and see what happens. This will be a learning opportunity. I'm not doing a system of equations with, there's 6 right now. We can get one of them by plugging in x equals -1. I'm not going to do the other 5, or the other 4 rather, the basic way. As a side note, systems of equations are really, really easy to solve with linear algebra. But linear algebra is like matrices and stuff. We haven't talked about it yet, so we're not going to do it. Okay, so let's use some strategic substitution. And let's see if we can use complex numbers. I'm pretty sure we can. Pretty sure. So if x is equal to -1, what do we get? 3 minus 1 plus 20 minus 3 plus 31 equals a. 1 plus 4 is 5 squared. Plus b plus c times, oh, that's just a big 0. And the next one, 0, 2. Great. 3 minus 1 is 2, plus 20 is 22, minus 3 is 19. We get 50. Equals 25a. So a must equal 2. All right, what happens if x is equal to 2i? That's the root, the complex root of this guy. If x is equal to 2i, what does the left-hand side become? 3 times 2i to the 4th power plus 2i cubed. All right, plus, it's going to be minus 20. The I squared becomes the minus 1, but then we also have the 2 squared as well. So it's going to be times a 4. It's going to be a minus 80 right there. Plus, again, when x is 2i, we're going to get 6i plus 31. And that's going to equal the right-hand side. When x is 2i, we get 4i squared, negative 4 plus 4 is 0. Great. So it's going to be 0 plus, again, another 0 plus that d times x, which is 2i, plus e times x, which is 2i, plus 1. Now we just keep simplifying. Fun, right? Complex numbers. Wait a minute, Jason. These are real valued functions. Why are we using complex? Wait, are complex numbers helpful? Are complex numbers meaningful and helpful even when we're not shoehorning them into mathematics? Yes, they are. By using complex numbers, we don't have to solve this freakishly gross, disastrous system of equations. Complex numbers are doing something for us even when we don't need them. You love to see that. You love to see that. Oh, nice. Okay. Whew, sorry, I actually got pretty excited about that. So this is 16 times 3, that's 48. And I to the 4th is what? Remember that the i's, right? They're cyclical. I squared is negative 1, and then that times I is negative I, and then that times I is positive 1, and they just cycle forever. And then we get I cubed is going to be a minus I. 2 cubed is 8. And then this becomes minus 80 plus 31 is minus, I shouldn't do this in my head, minus 49. Great. And then we have a plus 6i. On the right-hand side, we'll want to FOIL that out. This becomes 4i squared times d, which is negative 4d, plus, that's the same one, plus 2id, plus 2ie, plus e. Let's combine like terms and write them in a nice form. 48 minus 49 is negative 1. Minus 8i plus 6i is minus 2i. The right-hand side, let's write the real part first. E minus 4d. And then the imaginary part. I times 2d plus 2e. Now, just like when we set polynomials equal to each other and the coefficients have to be equal, for complex numbers, the real and the imaginary part also have to be equal. So what we have here, we can just look at two situations, right? What does the real part look like? Negative 1 has to equal e minus 4d. And the imaginary part, negative 2 is the imaginary part of the left-hand side, is equal to 2d plus 2e, the imaginary part on the right-hand side. Now, if we multiply the second equation by 2, what do we get? Multiply both sides of that second equation by 2. Now we can add these two equations together. Elimination method, really nice. If we add them together, we're going to get negative 5 is 5e. Ooh, that's nice. Oh, wait. Oh, oops. This is really bad, something I did. We should write things in the right order. This is negative 4d plus e. The d's still cancel. We still get 5e, but it's really easy to make a mistake the way I wrote it. So e is just negative 1. That's super nice. Okay. And then we can use that to solve for d. If e is negative 1, we get negative 1 equals negative 4d plus e. Negative 2 is negative 4 times d. D is a half. So we know A, we know E, we know D. And this is the bad part. We have to now use the other method, right? If you have repeated roots, if you have repeated factors, strategic substitution only gets you so far, even with complex numbers. Now we got to take this whole thing that we started with, this whole white thing up top, use what we know about A, use what we know about the other two letters, I forget, and see what we've got. All right. So it's going to be, let me pull it up on a different monitor so I don't have to tab back and forth. If 3x to the fourth plus x cubed plus 20x squared plus 3x plus 31, and that's equal to A, which we said was 2 times x squared plus 4 quantity squared. We'll have to simplify that. And then plus bx plus c. Oh, we don't know bx or c. Or we don't know b or c. And that's going to be one of these guys. Plus, now we do know this last part, e is negative 1 and d is a half. So negative x plus a half times this last part, which is x plus 1. Oh, and there's an x plus 1 on this guy too. All right, and now we got to FOIL this out. And then we can look at coefficients, just the coefficients that we need for B and C. All right, so let's get into it. So I'm going to leave the left-hand side alone for a second. And this is going to be 2 times, this becomes x to the fourth, plus 8x squared plus 16. Plus bx plus c. When you FOIL this out, x cubed plus 4, plus x squared plus 4x plus 4. And this last one becomes negative x squared minus x plus a half is minus a half x plus a half. Now, we can actually simplify some more if we want to, but we don't have to. Let's just look at the coefficient of x to the fourth. Why did I do that? I want the highest coefficient possible because that's going to be fewer terms, probably. And then let's look at all the x to the fourths. We're going to have a 2x to the fourth here, a bx to the fourth, and I think that's it. So 3x to the fourth has to equal 2x to the fourth plus bx to the fourth. Oh, b has to be 1. Okay. Great, and let's do something similar for c. Let's look at the cubes. That says coefficient. So 1x cubed. There's no x cubes here. Okay, there's a hidden one here. Be very careful about that. So plus bx cubed. B is 1. And then we have cx cubed. That's the only one. Oh, c is 0. That's my favorite, c. Okay, let's put it all together. A is 2. B is 1. C is 0. D is negative 1. And E is a half. So, the moment of truth is 3x to the fourth plus x cubed plus 20x squared plus 3x plus 31 all over x plus 1 times x squared plus 4 squared. Wait, I can check my answer. This one is in the book. Well, whatever. Let's get the suspense. Is that equal to 2 over x plus 1 plus bx plus c is 1x plus 0, x squared plus 4, plus dx minus x plus a half times x squared plus 4 squared. Wait, I don't think it is. I think I looked at the answer in the back of the book. 195. 2 is right. X is right. And then they had something else at the other one. Our E and F are somehow wrong. Unless that book is wrong. Let's check our answer. Let's graph this. All right, I'm typing so much. Because it seems weird. 3x to the 4th, x cubed plus 20x squared, plus 3x plus 31, all divided by x plus 1 times x squared plus 4 squared is equal to a over x plus 1 plus bx over x squared plus 4 plus negative x plus a half over x squared plus 4 squared. That looks pretty good. What about the books? What about the book's answer? The book's answer, their E and F is just it's just -1 over here. Oh, it's also right. Why is their answer nicer than mine? Are they equivalent? Does this simplify somehow? That's bizarre. Oh, all right. Well, we got the right answer. That's good enough for me. Let's move on to the next one. I'll think about that some more. 215. Use substitution to convert the integrals and then use partial fractions. Integral of e to the x over e to the 2x minus e to the x. Now, just like this one that we saw earlier today, this screams u substitution. We have a bunch of exponentials, and the derivative of an exponential is itself, which we have up there in the top next to dx. If u is e to the x, du is e to the x dx, which is great, because we have that. And then just as a side note, remember that e to the 2x is e to the x squared. So that'll be u squared here. All right. So when we look at that, we do a u sub. Again, this is just u, or du. We're going to be with 1 over u squared minus u du. And, oh wait, we already did this. We already did this. This was, this is the same as example 3, just with a different u. Where's example 3? It's negative natural log of u plus natural log of u minus 1 plus c. So there you go. That'll be negative natural log of u plus the natural log of u minus 1 plus c. What is that first guy? That first guy is just x with a negative in front. Nice. Second guy doesn't simplify at all. All right. We do need the absolute values because we don't know what x is. And the book has a slightly different answer for this one, specifically this part. The book writes like this. Am I wrong? Well, not here anyway. Because notice this answer is just factoring out a negative from what I have. And the absolute value of negative something is the absolute value of positive that something. So it really is the same. 229 should hopefully be another fun one. Use the given substitution to convert it and then do it. We got the integral of 1 over the square root of x plus the cubed root of x. And it wants you to use the substitution x equals u to the 6. So not a traditional u substitution, kind of a backwards u substitution, just like trig integrals. All right. So what is that going to look like? Oh, I just confused myself. My monitor moved around. So we know that dx will be 6u to the 5th du. Let's just see what happens. We get 1 over square root of x, which is u to the 6th, plus the cubed root of x, which is u to the 6th, times dx, which is 6u to the 5th du. I have no idea where this is going. It just looked like a fun, weird problem that I thought could be useful to do. Ooh, don't scroll down. I really should just start. The only reason I don't scroll down is so I can export these as PDFs, but I really should just scroll them down for long problems. I think it would make it look a lot nicer. Anyway, that's unrelated to you guys. We can factor the 6 out in front. This is u to the 5th. We get the absolute value of u cubed. Can I get rid of the absolute values? Do we know whether u is positive or not? Yeah, we do. Because x has to be positive. If x has to be positive, well, I mean, u's always going to be positive. Or wait, no. It doesn't matter whether u is positive or negative. Actually, it doesn't matter whether you use positive or negative. So in an arbitrary case, since it doesn't matter, we can choose to let it be positive. We can choose to let it be the same because of this substitution. It's kind of arbitrary. We'll write this as u cubed plus u squared. Now we could do another substitution maybe. It wouldn't really be helpful. Notice that the power, the degree on the top is bigger. So let's divide it out and make our lives a little easier. U cubed plus u squared. Let's do this off to the side. How does that divide? Again, if you really want to be precise, you just keep doing this, right? Those zeros. What do we need to multiply by to get a u to the 5th? The answer is u squared. That gives us u to the 5th plus u to the 4th. We subtract it out. Now we have minus u to the 4th. Well, what do we need to multiply by to get a u to the 4th with a negative? Minus u. That gives us negative u to the 4th. Ugh. Minus u cubed. Subtract that out. We get u cubed. And again, we're bringing things down, but we're only bringing down zeros, so I'm not writing them. Oh, okay, then we need to multiply by a 1. That gives u cubed plus u squared. I'm writing behind my head again, aren't I? Soon. So we subtract that out, and we get minus u squared as our remainder. This is 6 times the integral of u squared minus u plus 1. And then the remainder minus u squared over u cubed plus u squared. We get to use partial fraction decomposition on this guy. First part of this integral, no problem. That's a quadratic. Second part, yeah, partial fractions. Ooh, no. Maybe not partial fractions. Ooh, I'm glad I did this problem. This looks fun. We could use partial fractions. And if we did that, and again, I am going to take a moment and just let's work with this blue stuff and leave the other stuff alone. Look at this blue stuff. If we factor the bottom, it's u squared times u plus 1. Oh, look at that. That's 1 over u plus 1. Nice. Huh. Did I do my long division wrong, or is that just something that happened? I don't know, but it worked out. So this is 6 times the integral of u squared minus u plus 1 minus 1 over u plus 1. No partial fractions required. Nice. I'll do a bonus problem. I want to do another partial fractions for you guys. So you get 6 times 1/3 u cubed minus 1/2 u squared plus u minus the natural log absolute value u plus 1 plus c. And u was, ooh, we don't know what u was. X was u to the 6th. We're assuming everything's positive here because x had to be positive for this to make sense. The u was x to the 1/6. let's do two things at once. That always gets me into trouble, but let's do it. Let's distribute the 6 as well. 6 times a third is 2. U cubed is x to the 3/6. X to the half. 6 times a half is 3. U squared is x to the 2/6, which is x to the 1/3. Cubed root of x. Plus 6u. U is x to the 1/6. Minus the natural log of the absolute value of u, 6th root of x, plus 1. I checked my answer with the back of the book for 229, and they say 6x to the 1/6. Oh, we got that. Minus 3x to the 1/3. We got that. Plus 2 root x minus 6. Minus 6 natural log of the absolute value, and we don't need the absolute value because we know it's all positive. Yep. Perfect. 0 mistakes. All right, let's choose. I want to choose another partial fractions for you guys because I didn't do too many. And I'm just not going to do the integral. I want to just show the actual partial fraction decomposition stuff. Let's do another one, something with repeated roots. Oh, there's really not that many bad ones. Come on, there's got to be a bad one somewhere in here. I want to do a bad one. This homework is easy. We did the only hard problem. Let's do 209. No, not 209. No, let's do 209. Yeah, sure. Why not? That's not the one I found, but maybe it'll be interesting. Integral of x cubed. We'll do the whole integral. Why not? Plus 6x squared plus 3x plus 6. All divided by, oh, for crying out loud. All right, x cubed plus 2x squared. Look at the degrees. We got to divide this. The degree on the top is 3. The degree on the bottom is 3. Yeah, okay. X cubed plus 2x squared is dividing into x cubed plus 6x squared plus 3x plus 6. I'll go through this fast. That'll give us x cubed plus 2x squared. Subtract it out. We get 4x squared plus 3x, and then a plus 6 is our remainder. So this is equal to 1 plus the remainder. 4x squared plus 3x plus 6 all over x cubed plus 2x squared. Let's factor that. That's x squared times x plus 1. Oh, wait, it said this is an irreducible quadratic factor. Why is it lying to me? Because this is not an irreducible quadratic factor. This is a repeated linear factor. Shame on you, textbook. Oh well, let's keep going. Okay, so now we need to use partial fraction decomposition. So again, we go off to the side and we say, all right, 4x squared plus 3x plus 6. By the way, if this can be simplified, we simplify it. Can the numerator be simplified? Can it be factored? The numerator, to factor it, we need something that multiplies the 24 that adds to 3. Nope, that's not going to happen. The numerator's prime. So we know that this is going to be some constant divided by x. And then it's a repeated factor, so there's going to be another constant time over x squared. And then another linear factor. No quadratic factors at all. Come on, textbook. What are you guys doing? I keep checking to see if I'm making a mistake. Wait, x plus 1. X plus 2. Keep checking. You think I checked? Yeah, x cubed plus 2x squared, which I did it everywhere else. But when you factor out an x squared, we're left with x plus 2. All right, and then you multiply both sides of this by the LCD. That's x squared times x plus 2. And what do you get? Well, you get 4x squared plus 3x plus 6 equals A, one of the x's cancels, but we still have the other x, plus B, both x squareds cancel, x plus 2, plus C, x plus 2 cancels, and we're just left with the x squared. Now we'll use strategic substitution where we can to make things easier. If x is equal to 0, we just get 6 is equal to 0 plus 2b plus 0. Great, b is 3. If x is equal to negative 2, that takes more work. 4 times 4 minus 6 plus 6, oh, neat, equals 0 plus 0 plus 4c. The c is 4. Because we get 16 is equal to 4c. Nice. But there's nothing else to plug in. And that's always going to happen with strategic substitution when you have repeated factors. So we got to do it the harder way. 4x squared plus 3x plus 6 equals ax. You can multiply this out if you want. You don't have to. X plus 2 plus b, which is 3 times x plus 2, plus c, which is 4 times x squared. And again, you can do this however you want, but you don't have to do the full method. We can just look at the quadratic terms. These are our only quadratic terms here. So 4 times x squared has to equal a times x squared plus 4. No, is it this nice? A equals 0? Maybe. Oh, I don't like this blue box here. That's a plus, dx like that. All right, well, what does this look like? Let's move this to the end. Again, it's kind of an unfortunate way that this program works. A is 0. So this is going to be the integral of 1 plus 0 over x plus b, which is 3 over x squared, plus c, which is 4 over x plus 2. And again, it's a good idea to pause here and check to see whether we did our partial fractions right. Right? Is 4x squared plus 3x plus 6 divided by x squared times x plus 2, is that equal to 3 over x squared plus 4 over x plus 2? Hey, look at that. Oh, we should zoom out so we can actually see more stuff. I wonder if zooming out is the reason why I got confused on that other one with me in the book. Can we undo all this? Yeah, we can. Yeah, let's check that book before I erased the stuff that the book had. What we had? Oh, all right, no, that wasn't it. It was worth a shot. So we know we did our partial, but it's not a proof, but it's a good quick way to check. And now we just integrate. Antiderivative of 1 is x. Use the power rule on the next one, where the power is negative 2, add a power, subtract, add a power, divide by that power. And the last one's natural log with a u sub. Should be our answer. Jason checks with the answer in the back of the book with 209. And it's negative 3 over x plus 4 natural log x plus 2 in absolute values plus x plus c. Beautiful. Easy. Let me know if you have questions. Best of luck. Bye-bye.